Alright, in this video we're going to talk about disjoint / mutually exclusive events. Okay, so disjoint and mutually exclusive, they mean exactly the same thing. Often you'll hear me just call things disjoint just because it's less words and easier to say than mutually exclusive, but they're the same thing. Okay, so events A and B are disjoint. All right, if they have no elements in common. Okay, so I can write this another way. I can say A and B are disjoint if and only if. Okay, if you don't remember this, this is shorthand for if and only if. IFF means if and only if. Okay, and this is a mathematical shorthand that you will see us use a lot in our discussion of probability theory, so this is something you want to keep in mind. All right, so they are A and B are disjoint if and only if A intersection B is the empty set. Right? So the way you would draw this, say you had a sample space, right? Here's A, B, right? Cannot overlap A, right? There's no elements that belong both to A and B. That's what it means to be disjoint. All right. Something I want to point out, just because students often get disjoint and mutually exclusive confused with independent. Independent is another topic that we will discuss later, but just for right now, I want to point out that independence and disjoint are two different concepts. Okay, so don't get those words confused. Disjoint and mutually exclusive, that's the same thing, but independent is something entirely different. Okay, and we'll talk more about that word later. Okay, so let me just go ahead and do an example. So, an example of disjoint events. Suppose A is that we roll an even side on a die, and B is the event that we roll an odd side on a die. Okay, so in this scenario, A intersection B, right? So A and B is the empty set because no elements are shared in both sets. So therefore, A and B are disjoint.